Okay guys, welcome to the Stockfit tutorial. Now in this tutorial I'm just going to show you exactly how the website works and what's included in your download, so it just makes a bit more sense. It could be a bit of a new concept to you if you're not familiar with G-code files and CNC files. So basically Stockfit is a library of already completely designed and machine setup files for the manufacturing of these items as you see them in our library. So you'll notice that we've got the Stockfit Academy up top here. This is where you can learn all the ins and outs of how we do things, how we design, how to upload files, how to change your tooling, how to do whatever it is. There's a full academy with a lot of content that's available there. But for the purpose of this little tutorial, I just want to show you exactly how the models work, what's included and what's excluded, so you've got some idea of what it is that you're actually purchasing. So for this exercise, we'll just select model A001, which is a built-in TV unit, quite a high level display. The TV display is quite high, and you'll notice that we've got the name, the serial number, the price. You can add it as you would do normal online shopping cart, and then you've got the file information table at the bottom. Now this is a non-parametric design, which means that it is statically sized. With the parametric designs, you can simply change some parameters and you will have a different size. In this case, it's not possible with a specific design. The CNC file, the CNC machine required to do this is a CNC router. We will be adding CNC laser and plasma and all kinds of other file formats a bit later. Then we've got the software environment, which is the Autodesk Fusion 360 platform. And then the file setup on this specific file is G+, or G code is the file format is G+, which works quite well on most platforms. And then we've got our board size, which is the 1.8 by 2.7 meters, which is your standard 6 by 9. And material thickness is 16 millimeters. And then you'll notice that we've got a couple of files included, which is your Fusion 360 file, which is your master file. And then we've got a step file and an OBJ file for your 3D rendering purposes. We've got a 3D PDF for assembly purposes, and then a bill of materials with all the tooling required in this file. Now you'll notice that once you select the little tabs over here, it just gives you a quick idea of what it can look like in different colors. Obviously, we're using our corporate website colors to give you some sort of idea of what it can be. And then the last one is a technical diagram where you can get the overall height or overall dimensions of this unit to get a sort of a better idea of how big it is. Now, I personally have this unit in my house. It is quite significantly sized, so it's, just please double check the sheet sizes and the size of the units. Usually the full sheets, the 6 by 9s, is simply because the unit itself is so large that it cannot be done with smaller panels, or you don't want to do a lot of unnecessary joinery. So make sure that whenever you purchase a file, that the board size over here is the exact size of what your capability or capacity is on your personal machine or machines that you have access to. It won't help if you download a file that is a full 6 by 9 and your machine can only accommodate a 1.2 by 2.4 meters board. So just please be on the lookout for that. So now basically, if you go through the entire purchase process of this, you'll be able to go into your orders, and on your orders you'll be able to go down and download this entire pack. Basically, if you click download, it'll download it to your desktop computer, and you can save it anywhere you want on your hard drive. And then basically you've got the content. So now, just for the purpose of the exercise, I'll show you what that looks like. If you download the file, you'll have a zip or a zip archive type of a WinRAR file. You can simply extract that to a folder name, and then you'll have the folder with all the content in it. Now in this file folder, you will have a couple of different things. You'll have the file formats folder, the G-code folder, a couple of images, a 3D PDF, and a bill of materials 3D technical design. So I think for the purpose of this exercise, we'll just start off with the standard technical design PDF. Now you'll notice you've got sheet 1 and sheet 2. Now, the way we've set it up here, this is your dimensions as you saw it on the website before. This is what we'll be building. On your second one, you'll notice that we've got 4 sheets set up here. And it says sheet 1. It's a 1 tool part file, which means you need 1 tool, which is a 6mm square bit in this case. And then the G-code file is A00104S, which is a serial number, board 1, part 1 of 1, 6mm, which refers to the square bit. Then sheet 2 would have 2 parts. It'll have a 3mm bit and a 6mm bit. Now it's for detailed little small inside detailed little corners. This is the front panel. So this is 2 tools part file, the 3 and the 6mm. And then you'll notice that we're obviously going to run the 3mm first, and it'll have file name of the 3mm and then the file name, which is part 2 of the 6mm, done on the same sheet. So you will load a board and you will run file 1 on the 3mm first, machine it all out, and then you will switch to the second file while keeping the material on the board, and then load the 6mm bit and then run the 6mm bit to cut out the panel. So the only thing is the 3mm bit just does a couple of detail inside corners that you might not be able to do with a 6mm. Then we go over to sheet number 3 in this case, which is again, it's a 1 tool part file, simple 6mm square bit, and you just run that file. And then the same for sheet 4, and then you'll have all the panels required to build this cabinet as we just presented it. So you'll notice that the sizes at the bottom here, those are full sheet sizes. That's the type of wastage that we'll be looking at, 2.7 by 1.8 meters basically. So you need 4 sheets to build this specific unit. That's the best way of nesting all these parts. In the end, we've tried a couple of different nesting profiles, and this is what worked out best because of the size of the panels. So that is basically the normal technical and bill of materials. So you'll need 4 sheets of 16mm, you'll need a 3mm and a 6mm bit, and off you go. You've got 1, 2, 3, 4, 5 G-code files that you can just simply load on the machine and then run. And these are the panels as you would get them out on the machine. So that's the first part. Now, what I would like to show you on the second part is to just the 3D PDF. Now, you might have to just click here and say, trust this document always, because it does load a 3D file. Now, this 3D file allows you to basically show and hide different components. So if I wanted to hide the doors, I can simply hide the doors and get an idea of what this cabinet would look like at the bottom. These are all included in your standard download. So if you order a file off Stockfit, this is what you'll be getting. This is a nice little assembly guide. You've got your top center unit with all the sub. So you've got the front panel backings, and then the decorative panels. So you can show and hide these things as you build this. You can also do a couple of different visual styles. You can do it in solid colors, which obviously doesn't work so well in this specific case. I usually like the illustration version or shaded illustration. Just give you some sort of idea of what it is that you're building. It's basically like a little 3D preview of what the cabinet looks like, and it's also a nice way of double checking where panels fit and see how to put this whole thing together. So I use the 3D PDFs in my workshop so that my team can actually take a look at how the whole thing gets put together. It just makes a bit more sense, because it can become quite overwhelming when you've got many parts and it's in a massive heap lying on the floor and you don't know where to start. So this is a nice little way of organizing the parts. But that with the normal technical, just say close all tabs. So you've got the technical PDF and you've got the 3D PDF, and then you've got a folder with some images. Now these are the images that you saw on the website itself. Again, this is wonderful if you just want to do your own little portfolio perhaps, or if you want to show customers. These are specifically included in our folder so that you can create your own little catalog, or sort of white label your own catalog, and people can actually start purchasing or ordering items from you without Stockfit being notified, or without having to take people to our website. Of course, you're welcome to do both, because the service that you're presenting to a client, in most cases, they won't be able to do themselves. So if you feel that you want to white label it yourself, you're more than welcome. That's why we included the images. Now, Just want to see where. Now we've got the images, we've got the G code, and as mentioned before, we've got 6 G code files or 5 G code files. That's board 1, board 1 of it. Board 2 had 2 files, a 3mm and a 6mm file. Board 3 had 1 file that was a 6mm file, and board 4 had a 1 file. Now these are the files that you will simply then select, copy, put onto a flash disk, hit the paste button, whatever, and then you can take your flash disk, and you can then copy these files onto your hard drive of your CNC router and run these files individually, and off you go. So that is basically the G-code files, and then you've got the different file formats. Now we've got our Fusion 360 file, and we've got a OBJ file and a step file. These are just basic 3D files. If you wanted to do a presentation for a client, you can always import the OBJ, the object file into your 3D rendering software, and you can just do a nice visual using 3D Studio Max or Cinema 4D or whatever it's called. I don't know. I use 3D Studio Max for presentations. So any 3D software, you can either import this or convert it. OBJ is kind of a commercial application, or let's say file format that is compatible with most software, I think. Or there should be some way of converting the STP file or whatever. So the idea behind this is just to give you a little bit extra so that you can at least import the models into a familiar software environment to do renders for clients, to show them what it will look like if they built that unit and put it in their own living room or whatever. Then the next thing is the Fusion file. So now, for the purpose of this exercise, I just want to show you how to upload the Fusion file and how you can use the Fusion file to alter your tooling parts and things like that. So I'll open Fusion 360, sorry, not 3D Studio Max, Fusion 360, and you'll notice on the left I've already created a Stockfit uploads folder, and you can simply click on the upload button and then drag and drop that file onto the window here, hit the upload. It might take a few seconds to upload. My internet isn't the fastest, so just please bear with me while it uploads. Done. Okay, so you just hit the close button. Now this model should be uploaded into Fusion. I can simply hit open. And there we go, it's loading. This might be a bit quick on your connection, it depends. So here we've got the 4 sheets, as mentioned earlier, with all the machine parts. It goes to in our case, because this is our last working space that we do before we save the model, we will be faced with the manufacturing tab. So if you go into the design window and take a look, then you can see this is the entire model. So if you wanted to alter the sizes, you'd be able to alter this in the design window and simply delete the map version of what we've got here. The map is a flat packing of this existing unit. So if you do alter this design, keep in mind that you will have to flat pack the unit yourself. Again, based on your sizes and how you join, how you cut files, whatever. The purpose of the exercise is not to force you to make our design exactly like we've built it. It is more a case of being able to either alter this design yourself, or you're welcome to use it as is. That's what we loaded up for in the first place, just to make your life a bit easier. But if you choose to alter this, you're more than welcome to, obviously. You'll just have to notice that the flat packing is done referring to this actual file. So it could cause a couple of hiccups if you just machine the G code as supplied. But I'm sure if you understand how to flat pack and to set up paths and so on, that it's not a problem. Then you can just simply alter this model and then do your own. But for this exercise, we will simply just go into the actual model, flat packed, all these panels that are pretty much ready to go, and you can start machining. If we go into the manufacturing tab over here, you'll notice that the first setup is for all of this. You've got tool 1, which is a pocket cut and a contour cut. Now, if you wanted to change the tooling, like I said earlier, this is done on a 6mm. But if for argument's sake you wanted to change this to a 4mm or whatever bit, let's say 8mm bit for argument's sake, then all you have to do is just click on this, edit that tool path, select a different tool in your library, select that tool, hit the select button, hit OK, and then your path can be updated with using your tools. This is done on a preset of a 6mm, but you might not have a 6mm in stock. You might have an 8mm or whatever in inches type of router bits that you might have in stock. Then you can just simply change your tooling. You might also have a tool changing machine that can switch between tool 1 and tool 2. What we've done here is we've got the 3D or the 3mm bit up as tool 2 on our machine. So in your case, if you've got a single spindle machine and you use this, even though it's tool 2, in most cases it should just pick it up as it should default to a single spindle type of thing. So keep that in mind. If you've got a tool changer, then you can obviously change all the tooling to whatever your requirement may be. And then these are the full sheet sizes for this job. So it's quite simple. I hope it makes sense. So all you have to do is just basically log onto Stockfit, shop for the model that you're interested in. Simply download the thing, access all the G-code files and everything in the folder that you need, upload that, and then within Fusion 360 you'll be able to machine this immediately. Now if you're not familiar with Fusion 360, but you do have a CNC machine that can read G-code, then you can skip this entire thing. You can simply copy the G-code onto a flash disk or onto your CNC machines and get going immediately. That's going for gold. But you might have to sort of reprocess these and export them when you post-process, export them in a format that is applicable to your specific machine. There are so many available here, so you might find the exact export for your machine. You might have to alter it ever so slightly, but the principle remains the same. So for the moment, we've got G+. I like to use G+, simply because it works on almost any machine that I've tested personally. So it works quite well, and there are quite a few of the others that also work. So it's not to say that the other G+ and GRBL and those type of files don't work. But again, you can export for the correct post processor for your machine if it is available. So yeah, basically you get G+ in the file. If you want to alter it, you just have to upload the Fusion file to your Fusion 360 account, and then you can machine it. Now, while we're here, I'd just like to mention, I do have a paid version of the software. So my G-code, as it is exported, has got rapid tool changes and rapid movements in between paths. So what happens is between this path and that path, the machine will move quite quickly. Now, if you're on the free version of Fusion 360, then you might have an issue with that, because I do know that if you set up your own paths on the free version, there is a bit of a delay or a slow down element between these different tool paths. I think personally that the guys at Autodesk Fusion 360 did this on purpose to slow down manufacturing capabilities in order to get people to apply and sort of buy the commercial version so they can get things done much quicker. Obviously, if you're running this as a business, get the paid version. It's got all the extra features. It's well worth it, and you've got the rapid tool movements, and your business can run quite efficiently. As a hobbyist and someone who does this for himself, it makes sense to slow things down a little bit and to sort of get that type of thing. But anyway, so I think we've got it all covered. I hope that you find this design cool. If you've got any ideas, please feel free to submit your ideas to us, and we would love to hear from you.